Hello everyone, this is Anupam. This is the first tutorial on the video tutorial series on timers in STM32F4Discovery board. In this tutorial series, we will understand what are timers, why we need timers, how to work with timers, and then we will create a cool electronic gadget with timers and STM32F4Discovery board. You can check out the website www.logicvoltage.com. You will find many other STM32F4Discovery tutorials at the website also. You can even check out the video store at the website. You will find very good video tutorial series there with a very less price. You can even get in touch with me also in case of any query. Just go to contact us page and fill up the form and I will reply. You can check out the forum also. For any tutorial related queries or any technical questions and doubts, you can post comment there and I will reply back there so that other people can also see the comments and what discussion is going on. Please make some donations so that we can create free tutorials as much as possible or keep the price very low. You are welcome to choose any amount as you like for donation. We will be highly appreciated. You can also support by subscribing my YouTube channel. Thanks. Okay, so now in this tutorial we will understand about timers in STM32F4Discovery board. Now the first thing is, what is a timer? Actually, most microcontrollers are equipped with one or more precise timing systems that can be used to perform a variety of timer functions, including generating events at specific times, determining the duration between two events, or counting events. For example, applications that require generating events include generating an accurate 1 Hz signal in a digital watch, or like keeping a traffic light green for a specific duration, or maybe communicating and sending data serially between two devices at a specific bit rate. These are all kind of examples where timers are used. Now next question is, why there is a separate specific peripheral timer for doing the timing functions? If you have seen my previous video tutorial series, then you will find that we have created a delay function like this on most of the programs. What delay function was doing is actually waiting for some time. And remember, we were passing some number when we called the delay function, and we were passing some particular number so that we get a delay time of any required second. For example, we were passing 168,000,000 to get a delay of 1 second. But this does not create an exact 1 second delay. It's inaccurate. But till now, we were just working with LEDs. So we never required a very precise timing delay. So till now, this was working fine for most of our purposes. But on some situations, we need very accurate timings, and these kind of delay functions will not work there. So on those situations, we use the timers. Through timers, we can generate very accurate timing waveforms, or also we can even count pulses. There are many situations where timers are used, and we will look on some of them in this tutorial series. Okay, so let's go to the reference manual of STM32F407VG microcontroller. Let's see the left section here, table of contents. Go down and find the timer section. Okay, as you can see that we have 4 sections on timers. Timer 1 and timer 8, timer 2 to timer 5, timer 9 to timer 14, and timer 6 and timer 7. In total, we have 14 timers here. We can use any timer. You can see that timer 6 and timer 7 are basic timers. Timer 2 to timer 5 and timer 9 to timer 14 are general purpose timers. But timer 1 and timer 8 are advanced timers. These advanced timers has more additional functionalities as compared to other timers. Okay, so now let's understand the timers in details and how to configure them in the program. Okay, now what we will do in this tutorial is we will use 4 LEDs and connect them to discovery board, and we will make the LEDs blink in a particular pattern using the timers. Let's say here we have 4 LEDs. And let's say these are the timings here. This is 1 second, then 2 second, then 3rd second, then 4th second, then 5th second, then 6th second, then 7th, then 8th, then 9th, and then 10th second. And this goes on forever. Okay, now what we want to do is we want the first LED to remain switch on for 1 second and then remain off for 4 seconds and then again on for 1 second and then again off for 4 seconds, and same goes on forever. And second LED will be on for 2 seconds and then off for 3 seconds and then again on for 2 seconds and then again off for 3 seconds, and this same continues forever. And third LED will be on for 3 seconds, then off for 2 seconds, and then again on for 3 seconds, and then again off for 2 seconds. And this same continues forever. And then fourth LED will be on for 4 seconds and then off for 1 second, and then again on for 4 seconds and then again off for 1 second, and this same continues forever. And all these 4 LEDs will follow this sequence simultaneously. It's not like that first LED will complete first the pattern and then second LED will start. They all will follow this pattern at the same time. And this timing delay will be exact. And for this we will use the timers. Okay, so now you have understood what we wanted to achieve here. Now next question is how to achieve. Let's see how to work with timers. Okay, so we have 14 timers in the STM32F4Discovery board. We can use any one. Let's say we choose timer 3. Okay, so we will use timer 3 for making the LEDs blink. Now timer 3 doesn't have its own individual clock. It gets its clock source from system clock. Our STM32F4Discovery board runs at 168 MHz. That means in 1 second makes 168,000,000 ticks. Now timer has limitation. We cannot run timer at 168 MHz. Its maximum speed is 84 MHz. That means in 1 second it will create 84,000,000 ticks. Now with timers we can say like this, that whenever tick reaches some particular value then do something. So in this case it will be 84,000,000 ticks in 1 second, and hence we can say like do something after every 100 ticks. So the timer will do that every 100 tick. Hence first event will be at 100 and next will be at 200 and then next will be at 300, and same goes forever. Or maybe we can say like do something after every 84,000 ticks. So that event will happen first at 84,000 and then next at 168,000 and then next at 252,000, and same goes forever. Now if you noticed one thing here, that this event is happening at every 1 millisecond, because 1 second is equal to 1000 millisecond and 1 second has 84,000,000 ticks. Then 1 millisecond has 84,000 ticks. So you can see that how we can tell timers to do something at particular number of ticks and then do something. And this way the events are happening at precise timings. But there are few other things which also you need to understand to make the timers work. Like here I said on every 84000 ticks do something. But problem is the timer doesn't count ticks greater than 65535 number. So it will happen like this. We have 0 count here and 65535 count here. Now let's say the timer started counting. Now it will start from 0 here, then reaches 65535, then again it will be 0, then again counting goes to 65535, and then again start from 0, and this continues forever. So when the total number of counts will be 8400000, then it will be 1 second. So you can see that if I say the timer that do something at every 84000 ticks, then it will never happen because the number will never come. The maximum it goes to 65535. We have to tell any smaller number than this. It's because that the register where this number is stored and incremented is a 16-bit register. So on a 16 bits, the maximum number you can store is 65535. Now you must be wondering that this is a very hard limitation. It will stop us from doing many things. Well, in reality, it's not. We can still do any timing events with this. Now here we have chooses timer 3. But we choose other timers, let's say timer 2 or timer 5, then it has 32-bit register. Hence the maximum count it can do is 4294967296. Hence a very big number. Okay, one more thing that you have to keep in mind is that here I said that our timer is running at maximum 84 MHz, but we could run it at any speed below 84 MHz, and this speed we have to choose on the basis of our requirement. Okay, so now you have some basic knowledge about the timers and how it works. Now we can focus on our LED blinking pattern task. This, if you remember, this was the figure that we have seen sometime before. Here we have 4 LEDs and we want the first LED to remain switch on for 1 second and then off for 4 seconds and then again on for 1 second and then again off for 4 seconds and then same goes on forever. And second LED will be on 2 seconds and then off for 3 seconds and then again on for 2 seconds and then again off for 3 seconds, and this same continues forever. And third LED will be on for 3 seconds and off for 2 seconds and then again on for 3 seconds and then again off for 2 seconds, and this same continues forever. And fourth LED will be on for 4 seconds and then off for 1 second, and then again on for 4 seconds, and then again off for 1 second. And this same continues forever. Now we will understand how we will achieve this LED blinking behavior using timer 3. Now if you noticed one thing here, that after every 5 seconds the behavior is repeating on all 5 LEDs. What we can do is we will assume this complete 5 seconds as a single time period. What I mean is I will set the timer to count from 0 to 65535, and this counting will be completed in this one single duration of 5 seconds. So at the start of first second the counting will be 0, and at the end of 5th second the counting will be 65535. And if you remember, this is the maximum value that can be counted. After this it will be again 0. So on every 5 second counting will start from 0 to 65535. Now next what we will do is we will make all the LEDs to go high at the start of every single 5 second duration. Thus at the start of all LEDs will be switched on. Now we will set that when counting reaches 13107, make the LED 1 to switch off. When counting reaches 26214, make the LED to switch off. When counting reaches 39321, make the LED 3 switch off. When counting reaches 52428, make the LED 4 switch off. And hence, when counting reaches 65535, then it will again start from 0 and all LEDs will again switch on, and this whole process again repeats. So now you can see that in this way we have achieved the required blinking behavior in the LEDs. Now one more thing is that we have to set the frequency of timer in such a way that the counting from 0 to 65535 will complete in 5 seconds. If you do some calculations, then you can find that we have to set the timer 3 in 13107 Hz, because we want 13107 ticks in 1 second. Okay, so now we have all the basic knowledge about the timers and how it works. So now we can start building the circuit using STM32F4Discovery board and LEDs. Now let me show you how our circuit will look, and then we will build the circuit. Let's say we have Discovery board here. Then we have 4 LEDs here. And we have ground pin here on the Discovery board. We will connect all negative sides together and connect it to ground pin on the Discovery board. Now we have 4 pins on Discovery board: PC6, PC7, PC8 and PC9. So we will connect PC6 to first LED, then connect PC7 to second LED, then connect PD8 to third LED, then connect PC9 to fourth LED. And that's all. Our circuit is now complete. Now you must be wondering why I have connected the LEDs to these 4 pins. Can I connect to any pin? Well, the answer is no. You cannot connect the LEDs to any pin here. Now, why is that? That I will explain in the next tutorial. Okay, so now let's build the circuit. Okay, here we have STM32F4Discovery board and breadboard. Let's put 4 LEDs one by one. Okay, now let's put resistors for each LED. Okay, so now let's connect PC6 pin from Discovery board to LED 1. Now connect PC7 pin to LED 2. Now connect PC8 pin to LED 3. And then connect PC9 pin to LED 4. Now connect the LED's negative side together. Now connect the ground pin from the Discovery board to negative sides of LEDs. Okay, so now our circuit is ready. Now we can start writing code for this circuit. Okay guys, in this tutorial we have learned about timers. What are timers in a microcontroller? How we use them? What's the working process? And then finally we have built a circuit for practically understanding the timers. In the next tutorial we will continue this and write the program and configure timers. Once again, this is Anupam from www.logicvoltage.com and thanks for watching. Bye.